Hey guys, sorry this video is a day late. I got a little busy yesterday, so I hope you guys are all doing well and making it through the end of the semester. We're getting there. So anyway, we will start this week. We're learning about the beginning or the introduction of the terrestrial carbon cycle. So if you guys remember back earlier in the semester, we kind of looked at this particular slide here. And, before we already went through the ocean, now we're going to be going through the terrestrial side of it. But there are some things in common. So first of all, there's going to be photosynthesis and respiration on both sides. We're also going to have a process where some of it's going to get buried and some of it is not. And most of it will not, actually. It'll go back up, the same as, in the ocean here. Okay, so there's a couple of terms that we really need to go over, which is where this is going to be like the introductory lecture on it. So first of all, we have the gross primary production, or GPP. This is the total biomass producers create in a given length of time. This is often a measure of photosynthesis. So basically what it is a measure of how much stuff is growing. Okay, so the next one is going to be net primary production. This is the leftover biomass that occurs after accounting for plant respiration. So NPP is going to equal the GTP, the GPP, not the GDP, the GPP minus the respiration of the plant. So this is everything that's left in the plant after respiration. Okay, so the next thing we want to look at is the controls of NPP. So the controls are going to be related to precipitation and temperature. You can see we're going to look at this graph over here where it has NPP on the y-axis and precipitation on the x. You can see that there's going to be a sharp spike and then a peak at a certain point here in precipitation. And it's on the drier side, actually. Once it starts precipitating more, then the NPP actually goes down. So there's going to be a peak somewhere closer to the drier side than the really, lots of precipitation side. And then if you look at the same thing, but look at the temperature on the x-axis, you can see that it just basically goes up through time. Up with temperature. So things that are on the drier side but high in temperature are going to actually have a higher NPP than things that are really, moist, situation with a higher temperature. And obviously lower temperature is not going to have very much NPP. So let's look at the global NPP and GPP. This is basically a ratio that we have going on right here. It's going to have, the higher point's going to be in the warmer colors, in the cooler, and in the lower ratio. So first of all, let's note here that in places like the desert, there's not going to be anything growing. So there are at least a very small amount of things. So it's not even going to be enough for them to have data on. But then let's look at something like the rainforest. You might expect this to be really high over a rainforest. But let's go back over here. A rainforest is actually has a lot of precipitation, right? It's right on the intertropical convergence zone. This is going to have a ton of precipitation and a high temperature. So it actually doesn't have a very high ratio based off of that. But, areas that do receive, some rain, like Arizona, that area over there here, but also are higher in temperature, those are going to have, so high, low amount of precipitation and high temperature. Those are going to be the areas that actually have the highest in the ratio. So that's going to be, the areas over here, like I was just saying, Arizona. I don't know if Nevada is probably a little bit far too west there, but, areas like that over here, also here down in the extreme south of South America, areas over here in Australia, South Africa, areas like that. Let's see, really cold up here, so the temperature is low up here, and So that's going to have the lower ratio, same as basically over here where it has the higher precipitation. Okay, so let's take a look at the NPP distribution across major biomes. Let's see. So different vegetation habitats grow in different ways. So if you look here, we can see the estuary, swamps, and marshes. These actually have the highest of the net primary productivity. The lowest is going to be the deserts, the open oceans, the tundras. Those kind of make sense. Rocky beaches, lakes and streams, these are going to have on the lower side, but these really high ones are going to be coral reefs, tropical rainforests, and then the estuaries. Now remember, this isn't the ratio, this is actually the net primary production, so just NPP by itself. Let's see. So you can also see how the climate change is going to affect the size of these biomes. It's also going to affect primary production. It's going to also be like, with respect to the carbon reservoirs on land and how much CO2 is taken from the atmosphere. So, different things are going to have a lot more photosynthesis than others. If you want to get rid of that, I think it actually ended up in the picture. But it's going to definitely affect, like, as the climate gets warmer, then we're going to have certain biomes that are going to, get larger depending on how much moisture that they receive. And then that's also going to affect how much of that reservoir, how much it's going to be able to hold of carbon, or how much it'll be affected. Okay, so let's next look at the net ecosystem production, or the NEP. This is going to include respiration for more than just plants. So this is the respiration for the entire ecosystem. It equals the respiration for autotrophs plus the respiration for heterotrophs. So autotrophs are going to be things like plants and algae. These are things that produce their own foods. They're commonly referred to as producers. And heterotrophs are actually going to be like animals, fungi, things that eat other consumers like us. And that's going to be considered a consumer. Or I said eat other organisms, not consumers. On shorter time scales, GPP and respiration typically dominate the carbon balance. And this balance is termed net ecosystem production. So NEP is going to equal the GPP minus the respiration of the complete ecosystem, not just that of autotrophs. Because remember that the NPP is taking out just the respiration of the autotrophs. Okay, so next we will go to the net ecosystem exchange, or the NEE. This is the CO2 flux from the ecosystem to the atmosphere, or the net CO2 exchange of an entire system. So we can, have this nice little graphic here. We can look at the source is going to be where the NEE is positive, and that is going to be where things are like flowing into the atmosphere. And then we have sinks where the NEE is negative, and those are where it's going out of the atmosphere and coming into the ecosystem. So source is going into the atmosphere, and a sink is going to be going down into the ecosystem, like down into the ground. Now, there is a seasonal variation to NEE. You can see that this is going to be our zero line right here. I want to also point out that this really terrible orange right here is going to be where it's all vegetation, so the average of everything. So anyway, look at this zero line right here. Anything above a zero is going to be a source, and anything below zero is going to be a sink. So, the deciduous forest is going to have a very large amount of sink in the summertime due to photosynthesis. I kind of would equate this to the Keeling curve. When you look at the ups and downs of the Keeling curve, and that's basically accounting for the seasons and photosynthesis, and as plants die. So same type of thing here. This just breaks it down to the different types of plants and how each one of them actually contribute to all vegetation, or the average. Okay, but how do we actually measure it? Basically we're measuring photosynthesis and respiration, which is not a very easy thing to actually try to estimate. So they have this thing, it's called an eddy tower, and what it's doing, and it has to be sitting above the ecosystem. It's measuring the wind coming in, and it's going to look at how the air is moving through it and measure the atmospheric pressure of CO2. And it also works best where it's flat. So if there's, any type of terrain, then you're going to have a harder time, taking this type of measurement. So that's where that variation in topography comes from. Another way is by inverse modeling. This is where we use variability on the uneven spatial distribution of CO2 levels in the atmosphere. So we're using variability to say, here's a source and here's a sink. And then it takes the model results and figures it out basically from there. So it's basically using what we already know about our own land or what is on the land. Okay, and then we have the net ecosystem carbon balance. That is going to be the NECB. This is the net rate of accumulation of carbon by an ecosystem. It's going to be the gaseous outputs minus the losses, the dissolved inputs minus the losses, the particulate inputs minus the loss. So, and it's going to look at it at each grid box, and it's going to try to figure out, based upon what's inside of that grid box, what its gains and losses are on each, in each type of thing. So, if this deer, is going to have certain gains and losses. Rivers and lakes, it's going to be like how much is dissolved. We're also going to be looking at particulates, moving things, erosion, migration of animals, that type of idea. And very few studies measure all of these components. It's really hard to do. I haven't personally seen this one very much, so just because it's real difficult. And then, the last one I would say is going to be, let's figure it out based off of what we know. So we know how much of the emissions from fossil fuels is, right? We can figure that out. We can figure out the emissions from land use change and the ocean uptake. So, and we know that the atmospheric increase is this much. So based upon this mathematical equation, we can figure out what the carbon uptake on land is based off of the other things that we do know. So not a direct measurement, probably not as nice and neat as you'd like to see, but it is, the best way that we can kind of come up with it most of the time. Okay, so that is everything that I have for you guys today. Please make sure to do your reading. I did put a quiz up based on what you guys read last week on the IPCC report. So let me know if you have any questions, and I will talk to you. I guess not talk to you guys, but I'll record another lecture next week.